Welcome. In this video, we will take a look at the U substitution method for integration. So the big idea with U substitution integration here is we want to get this function of x that's inside my integral dx into a form where we can write it as an integral of a function of u du. And we'll try to do that by first establishing a u variable that is substituted inside that integral. And what we're looking for in terms of a u variable is we're looking for maybe a more complex part of this integral that has its derivative kind of hidden inside of the function somewhere. So for this example, the more complex kind of portion of this integral would be the denominator, x squared plus 1. It's a power above or a degree higher than the numerator. So we're going to start by just choosing x squared plus 1 as the u substitution. And we'll take a look also at a du function, the derivative of the u function. And that would happen to be 2x dx. Now, with the d and the du function here, I want to go out and substitute everything inside the current integral and make it an integral in terms of u. So there's a couple things that we want to keep in mind. The constants in our integral, they can come out of this integral, and we don't have to account for them inside that integral. So let's consider what we have so far. I've accounted for the u in my denominator, so I have that ready to go. And now I'd like to go out and account for the x dx combination. And notice that I have a way to do that if I rearrange my du function. So if I rearrange my du function and divide by 2, I can get that du over 2 is equal to x dx. So this substitution that I have right here, x dx, can account for the remaining pieces in my integral. Again, with our 5, we can bring outside the integral. So let's go and see if we can rewrite this as a function of u inside my integral du. So I start with that 5 constant on the outside. My initial u substitution sitting in the denominator, we'll just put a u right down there. And then the x dx that's in green there, we can substitute in a du over 2. So this will be really 1/2 times du. So here I have a function of u inside my integral du. And now I'm going to take my antiderivative in terms of u. So one little thing I can do here is pull out my constants again. This 2 is a constant I can pull out. And so we can write this as 5 over 2 integral of 1 over u du. Now I just want to take the antiderivative of 1 over u. We know that to be the natural log of absolute value of u. So this will be 5 over 2, natural log of absolute value of u, and then we'll add our plus c here. And the only thing that I have left to do here is go back to my u substitution. So we're starting and ending this process with the u substitution. So when we do that, we can rewrite this one more time as 5 over 2 natural log of, my substitution was x squared plus 1. And we're going to take the absolute value of that plus c. And this is our final solution for our integral using the u substitution method.